Welcome to the Deep Dive. We're diving into the history of astronomy today, all thanks to that fascinating article you sent over.
Oh, it's a fantastic read, isn't it?
Yeah, it really is. So we're basically gonna explore how humans went from just looking up at the stars, to understanding this crazy, huge, and complex universe we live in.
It's quite a story. And it
Mhm.
really is remarkable how, over thousands of years, humans went from just, basic observations to these really intricate theories and incredible advancements.
It really makes you think, what did those early humans think when they looked up at the night sky?
Right.
I mean, the article mentions how they used the stars for practical things, like when to plant crops or go hunting.
Mm-hmm.
But there must have been a sense of awe, too.
Absolutely. I mean,
Well,
think about it. These early humans were so incredibly observant.
yeah,
They used constellations and natural landmarks to actually track time and, organize their
I
lives. And we see this fascination with the cosmos in cave paintings, almost like they felt this need to capture that sense of wonder.
it's like finding, ancient stargazing selfies.
Totally.
But then as civilizations developed, their astronomical knowledge also developed. Just think about the Egyptians and their incredible structures,
Mm.
like the pyramids and obelisks.
Yeah, and a lot of those structures were precisely aligned with celestial objects.
Oh, really?
Which shows a deep understanding of how the stars move.
It's fascinating, right? They combine this practicality with a sense of cosmic connection.
For sure.
I've always been curious about the pyramids, though. There are so many theories out there.
I know.
Some people think they were built with the help of aliens,
Yeah.
especially because of the, mathematical principles, like pi,
hmm
that are incorporated into their design.
Yeah.
What do you think about that?
Well, it is true that the pyramid's construction does incorporate mathematical principles like pi, but it's way more likely that the Egyptians, figured this out on their own. They were brilliant engineers and mathematicians, and honestly, their achievements really show off human ingenuity.
So no need to bring aliens into it.
Right.
Though, while we're on the topic of mysterious ancient structures, what about Stonehenge?
Oh, yeah.
What role did astronomy play there?
Well, Stonehenge is another, really compelling example, although, to be honest, its exact purpose is still up for debate.
Okay.
However, we do know its alignment with solstices and equinoxes shows a pretty sophisticated understanding of, the sun's movements. I mean, all these ancient cultures were so connected to the cosmos.
It's incredible how they integrated astronomy into their lives, even their architecture. But how did we go from those early observations to the complex scientific models we use today? I mean, it wasn't always a straight path, right?
Definitely not. For centuries, the, main model of the universe was geocentric. So, Earth was at the center.
Uh-huh.
And this was largely influenced by philosophers like Aristotle. It makes sense, though. Imagine looking up and seeing the sun and stars seemingly moving around you.
Right.
It's understandable why that view held sway for so long.
It makes total sense from an earthbound perspective.
Yeah.
But then Copernicus came along and shook things up with his heliocentric model. So that put the sun at the center of the solar system. That must have been a totally radical idea at the time.
It really was.
Did people immediately accept it?
Not really, no. While Copernicus's model was revolutionary, it didn't have, the solid evidence needed for everyone to accept it.
Oh,
But it did set the stage for, other astronomers to, come along and find that evidence.
that's where Kepler and Galileo come in, right?
Exactly.
What do they add to our understanding?
Well, Johannes Kepler,
Cool.
he refined the heliocentric model because he discovered that, planets don't orbit the sun in perfect circles.
Oh.
Yeah, instead they orbit in these, elliptical paths. And his laws of planetary motion are still, fundamental to astronomy today.
Wow. So Kepler added this whole new layer of complexity to our view of the solar system.
Mhm.
What about Galileo? He's famous for the telescope, right? What did his observations reveal?
His observations were huge. I mean, they provided the concrete evidence needed to really support the heliocentric model. He observed the phases of Venus similar to the phases of our moon,
Oh.
which wouldn't be possible if Venus orbited the Earth.
So that was a major aha moment for people.
Definitely. It really helped shift everyone towards the heliocentric model.
It's amazing how a single observation can have such a huge impact.
It really is. And, what's really fascinating about Galileo's work is that it demonstrated the importance of empirical observation and experimentation in scientific progress.
Yeah.
He challenged the established dogma based on what he could actually see and measure,
Right.
and that approach became like a cornerstone of modern science.
He was a true pioneer. It's incredible to think how far we've come from observing the stars with the naked eye to, like, actually using telescopes to prove groundbreaking theories.
Yeah.
But I'm curious, how did early astronomers actually figure out the distances in space? I mean, they couldn't exactly grab a measuring tape, could they?
They had to get creative. Like, they used techniques like triangulation and parallax to calculate distances.
Parallax. Can you explain that a bit more?
So it's based on the idea that objects appear to shift position when you look at them from different places. So, like, hold your thumb out in front of you and close one eye, then the other.
Okay.
See how your thumb seems to jump.
Yeah.
Well, astronomers use a similar principle, but with stars. So by observing a star from different points in Earth's orbit, they can actually calculate its distance.
That's really clever. But I'm guessing there were more technological advancements that helped astronomy really leap forward. The article mentioned photography playing a big role.
Oh, for sure. Photography was revolutionary for astronomy. Like, instead of relying solely on sketches, which could be subjective and imprecise,
Right.
astronomers could capture and preserve detailed images of celestial objects using photographic plates.
Right.
This led to way more accurate recordings and analysis.
So no more, like, scribbling in the dark.
Exactly.
And along with photography, the article mentioned something called spectrographs. What do those do?
Well, spectrographs basically let astronomers study the light from stars and galaxies. They split the light into its component colors, almost like a rainbow. And by analyzing these spectra, they can determine the chemical composition, temperature, and even the motion of celestial objects. Like, there are these cosmic fingerprints that tell us secrets about the universe.
That's incredible. So we've gone from naked eye observations to telescopes to photography and these spectrographs. It's like each advancement brings us closer to understanding all these complexities of the universe.
It really does.
And speaking of understanding the universe, that's where Edwin Hubble comes in, right?
Yeah.
He made some discoveries that, like, totally changed our perspective on the cosmos.
Absolutely. Edwin Hubble's observations were truly revolutionary. He was the first to prove that the Milky Way, our galaxy, was just one of many galaxies in the universe. It wasn't the entirety of it, as we previously thought.
That's crazy to think about.
It really is. And on top of that, he discovered that the universe is expanding.
Wait, the universe is getting bigger. How did he even figure that out?
Well, he observed that distant galaxies were moving away from us,
Okay.
and that the farther away a galaxy was, the faster it was moving away.
Interesting.
So this observation led to the theory of the expanding universe, which is like a cornerstone of modern cosmology.
Wow. So, like, the universe is constantly stretching outwards in all directions.
Exactly.
And how do we even measure something like that?
Well, Hubble actually built on the work of other astronomers,
Okay.
including a woman named Henrietta Leavitt, who had discovered this like special relationship between a star's brightness and its pulsation period.
Mhm.
And this relationship allowed astronomers to measure distances to faraway stars and galaxies.
Gotcha.
So it was a crucial piece of the puzzle that Hubble used for his discoveries.
So Hubble's success was built on the work of others, particularly women in astronomy, which the article really highlighted.
You're right. It's important to recognize that scientific progress is rarely a solo effort.
It's true. And sadly, the contributions of women in astronomy were often, overlooked.
Yeah.
You mentioned Henrietta Leavitt.
Mm-hmm.
But there are so many other women who made big contributions but weren't always recognized for their work.
Uh-huh.
Their stories are really inspiring.
Absolutely. It's a good reminder that the history of science isn't always fair or inclusive. Like,
Yeah.
it's important to acknowledge those who've been marginalized and, celebrate their achievement.
It really is. And speaking of celebrating achievements, who are some of the other, like, unsung heroes of astronomy that we should know about?
Oh, there's so many. Caroline Herschel, for example, she was this brilliant astronomer in the 18th century who discovered a ton of comets and nebulae. And, she did all of this while working alongside her brother, William.
Mm.
And, she faced a lot of challenges as a woman in science during that time, but still, she persevered and made significant discoveries.
It's amazing to think about all the obstacles she must have overcome to pursue her passion for astronomy. Who else comes to mind?
Well, in the early 20th century, there was Cecilia Payne-Gaposchkin. She completely revolutionized our understanding of stars. Like, By analyzing their spectra, she figured out that they are mostly made up of hydrogen and helium.
Really?
Yeah, and at the time, that was a really radical idea.
So stars are mostly just hydrogen and helium. That's crazy.
I know, it's pretty wild. Her work was initially met with skepticism, but her, meticulous analysis and commitment to scientific rigor eventually won over the scientific community. I mean, her work basically changed how we understand stars.
It's so inspiring to see how these women push the boundaries of scientific knowledge.
Absolutely. Their stories highlight how important diversity in science is. And, we need to recognize and celebrate the contributions of everyone who wants to explore the universe's mysteries.
For sure. Well, I think we've covered a lot in this first part of our dive. From early observations to groundbreaking discoveries that reshape our understanding, it's been quite a journey.
It really has. It's remarkable how much human curiosity and ingenuity have revealed about the cosmos, but there's still so much left to explore.
Exactly. Stay tuned for part 2 of our deep dive, where we'll delve further into the modern marvels of astronomy and all the mysteries that keep scientists captivated today. Welcome back to the deep dive. We've been, exploring the incredible history of astronomy, from those ancient stargazers to the, revolutionary discoveries of Copernicus, Kepler, and Galileo.
Yeah, it's really amazing to think how much our understanding has changed over time.
Totally. And before we move on to, all the modern stuff, I wanted to touch on something you mentioned earlier about Galileo's approach to science.
Yeah.
You said how he, challenged those old beliefs, the dogma, based on what he could really observe and measure.
Exactly. His focus on empirical evidence, it basically became a cornerstone of the scientific method. And not just in astronomy, but, across all kinds of science. It's about, testing those ideas, gathering the data, and letting the evidence guide you to the conclusions.
That's a powerful way to approach things, and it's led to so many breakthroughs in our understanding. But speaking of breakthroughs, we can't forget about those, amazing women who made huge contributions to astronomy, often while facing, challenges and discrimination along the way.
Right.
We talked about a few of them earlier, like Henrietta Leavitt and Cecilia Payne-Gaposchkin.
Yeah.
Their work was seriously
It
groundbreaking.
really was. They challenged all those old ways of thinking, and they expanded our knowledge of the universe in, such profound ways. Their stories are so inspiring, all that perseverance and intellectual curiosity.
It's amazing.
Yeah.
But let's shift gears a little bit and dive into some of those more recent developments in astronomy. We were talking before about Edwin Hubble and his discovery of the expanding universe.
Mm-hmm.
That's a pretty mind-blowing concept.
Yeah.
Can you explain a bit more about how we know the universe is expanding?
It all boils down to something called redshift. Okay, so think about the sound of a siren as an ambulance approaches and then moves away from you.
Okay, yeah.
The pitch of the siren, it sounds higher as it gets closer and lower as it moves away. That's called the Doppler effect.
Right. I remember that from physics class. So how does that relate to the expanding universe?
Well, light also behaves like a wave, and it can experience a similar Doppler effect. So when an object is moving away from us, the light waves, they get stretched out. And that causes a shift towards the red end of the spectrum. That's what we call redshift.
Oh, I see. So by observing the light from those distant galaxies and measuring their redshift, astronomers can figure out how fast they're moving away from us.
You got it. And what Hubble observed was that the farther away a galaxy was, the greater its redshift, meaning it was moving away from us faster. This was a big piece of evidence that the universe is expanding.
It's like the universe is always stretching out. But what's causing that expansion? Is there some kind of force pushing everything apart?
That's a really great question. And it leads us to one of the biggest mysteries in astronomy. Dark energy.
Dark energy. I've heard about dark matter. But dark energy, what is that exactly?
It's this mysterious force that seems to be driving the accelerated expansion of the universe.
Yeah.
We know it exists because, we observed that acceleration, but we don't actually know what it is or how it works.
So it's like this invisible hand just pushing everything apart, and we have no clue what it's made of or how it even works. That's kind of creepy, isn't it?
It is. It's one of the most fascinating and perplexing questions in cosmology today. We can kind of guess it's there because of its effects on the universe's expansion, but we haven't figured out its true nature.
Sounds like there's still so much we don't know.
Yeah, there is. But, that's also what makes it so exciting, right? Every discovery just opens up these new paths to explore, and it leads to even more questions. It's this constant search for knowledge.
It's a never-ending journey.
Yeah.
Speaking of new discoveries, the article mentioned gravitational waves.
Oh, yeah.
That was a really big deal in the science world, wasn't it? Can you explain what they are and why they were such a big discovery?
Gravitational waves are these like ripples in space-time, almost like, when you drop a pebble in a pond and the waves spread out.
Okay, I can picture that.
They were actually predicted by Einstein's theory of general relativity way back when, but they were super hard to detect
Why is that?
because they're incredibly faint.
Oh, okay. So what causes these gravitational waves? Like dropping the pebbles in the cosmic pond?
Well, they're created by some of the most violent events in the universe. Things like black hole mergers, neutron star collisions, even the Big Bang itself.
Wow, so they're like cosmic echoes of these massive events. But if they're so faint, how did we finally detect them?
Well, it took a lot of time, decades of research and constantly improving our technology. But in 2015, scientists at this place called LIGO, the Laser Interferometer Gravitational Wave Observatory, they made the first direct detection. They detected waves from, get this, the merger of two black holes billions of light years away.
Whoa, so can we actually hear these cosmic events happening?
Not in the way we usually think about hearing sound, but
Yeah.
those detectors, they can measure how space-time stretches and squeezes because of these waves. It's like a whole new way of listening to the universe.
That is so cool. So what kind of information can we get from these waves?
They actually carry information about the objects that made them, like their masses, how fast they spin, and how far away they are. So this helps us study, black holes, neutron stars, all those weird objects. It's like opening up this whole new window to see into the universe.
It sounds like gravitational wave astronomy could really change how we understand the cosmos.
It really could. It's a super fast developing field, and it's going to reveal so much more about the universe, I think. We're still just starting out with this, but the possibilities are endless.
It's mind-blowing.
Yeah.
From observing redshift to actually detecting gravitational waves, it's crazy how far we've come in understanding the universe.
Yay.
But there's still so much we don't know, isn't there? Like dark energy and dark matter, those are still huge mysteries.
You're right. Those are some of the biggest challenges for astronomers today. We know dark matter exists because of how it affects gravity, how it affects all the stuff we can see, but we still haven't figured out what it's made of.
So it's like this invisible stuff holding everything together. And dark energy, well, we know it's causing the universe to expand faster and faster, but
Yeah.
we don't know what that is either. It's almost like the universe is playing hide and seek with us.
Haha, that's a great way to put it. But, I think that's part of what makes astronomy so fascinating.
Yeah.
There's always something new to discover, Always another layer to peel back. More questions than answers.
That's true.
It makes you want to keep searching.
And as we keep developing new technologies and tools, like all those amazing telescopes and detectors, who knows what we'll discover? What other secrets the universe will, show us?
It's a really exciting time to be studying the cosmos. Each new observation, every new discovery, it brings us closer to understanding our place in this vast universe.
Well, I think we've covered a lot in this part of our deep dive. From the expanding universe to those gravitational waves, we've explored some crazy concepts.
We really have.
But there's still more to come. So stay tuned for the final part of our journey through the history of astronomy.
Welcome back to the deep dive. It's been quite the journey through the history of astronomy, hasn't it?
It really has. From those early sky watchers, mapping out the constellations to modern astronomers grappling with dark energy and gravitational waves.
It's amazing how far we've come. And one thing that's really stuck with me throughout this whole thing is how collaborative science really is.
Oh, absolutely. It's not just about, those individual geniuses making those big breakthroughs. It's about building on what others have done before,
Yeah.
sharing knowledge, working together to solve these big cosmic puzzles.
Totally. Like we've been talking about, right? Hubble's discoveries, they were built on the work of Henrietta Leavitt. And Galileo's insistence on actually observing and measuring things, that paved the way for so much progress. It shows that science is a team effort.
For sure. And speaking of those who came before, I wanted to circle back to some of those unsung heroes we mentioned.
Yeah.
We talk about Caroline Herschel, who discovered comets and nebulae way back in the 18th century.
Mm-hmm.
What were some of the challenges she faced as a woman in science back then?
Oh, she faced a lot of them. I mean, science was pretty much a boys' club back then.
Yep.
Women weren't really given the same opportunities, like education or recognition. But Caroline, she was a total rock star.
I bet.
She worked so hard right alongside her brother, William, honing her skills and making all these discoveries on her own.
Her story is so inspiring. Imagine making those discoveries while facing all those barriers. It really shows how important it is to, like, recognize and celebrate everyone's achievements, especially those who have been, like, pushed aside throughout history.
Absolutely. We need to tell those stories and make sure those contributions aren't forgotten.
For sure. And, speaking of inspiring figures, we can't forget about Cecilia Payne-Gaposchkin.
Oh, right.
Her work on stellar composition was revolutionary. But it wasn't accepted right away, was it?
No, not at all. Back then, everyone thought stars were made of the same stuff as Earth.
Mm.
But Cecilia, she analyzed all those stellar spectra and came to this radical conclusion. She found that stars are mostly hydrogen and helium.
Wow, really? I mean, that's completely different from what people thought.
I know, right? And it really shook things up. People were skeptical at first.
Makes sense. So what happened? Did her work eventually get the recognition it deserved?
It did. But it took some time. More research basically proved she was right, and now she's, super well known for her work on how stars evolve. A real pioneer for women in science.
It's amazing how she stuck to her findings and, changed how we understand stars.
It really is.
But okay, let's shift gears a little bit and look ahead.
Okay.
What are some of the exciting things happening in astronomy right now? What are the big questions keeping astronomers up at night, so to speak?
Well, one really exciting area is the search for exoplanets.
Exoplanets.
Yeah, those are planets that orbit stars other than our sun. We've already found thousands of them.
Wow, thousands.
And some of them might even be able to support life.
Imagine finding another planet out there with life on it. That would be incredible. What are some of the challenges in finding these exoplanets?
Well, it's really hard to see them directly. They're usually pretty faint and they're really close to their stars.
Ah, makes sense.
But astronomers are clever. They've come up with some pretty ingenious methods to detect them.
Like,
Well, one way is to look for a slight dimming of a star's light when a planet passes in front of it.
oh, that's clever.
Yeah, and another is to measure tiny wobbles in a star's position caused by the gravity of an orbiting planet.
So it's like this giant cosmic game of hide and seek.
Exactly. But astronomers are like expert detectives.
What about the search for life itself, beyond Earth? Is that something astronomers are working on?
Oh, definitely. Astrobiology is this booming field that's all about looking for life beyond Earth. Scientists are figuring out what conditions are needed for life to exist.
Uh-huh.
And they're searching for any signs of life on other planets or moons in our solar system and beyond.
It's mind-blowing to think that we might not be alone in the universe.
Right.
Maybe there are other life forms out there, even intelligent ones, looking up at their own night sky, wondering the same things we are.
Right. It's both humbling and super exciting to think about.
It's one of the biggest questions humanity has ever asked.
It really is. And as our technology keeps getting better, who knows what amazing discoveries are waiting for us.
I can't wait to find out. Well, I think we've covered an incredible amount in this deep dive. We've journeyed through the whole history of astronomy, explored what's happening in research right now, and talked about some of the biggest mysteries out there.
We really have. And what's amazing is that this journey of discovery isn't over. There's so much more to learn, so many more questions to ask.
The universe is such a vast and mysterious place. It's full of possibilities and wonder.
It really is.
And as we keep exploring, keep observing, keep asking questions, who knows what the universe will reveal to us next? Thanks for joining us on this incredible deep dive into the history of astronomy. We hope you enjoyed the journey.